Alrighty. Happy Wednesday, everybody. It's time to move on to Chapter 5. We're going to do some new stuff. Let me fire up NetBeans here. I should have done that earlier. This always takes forever. Good morning, Wolf. All right, so Chapter 5 is all about methods, and then a little bit around doing some data validation and how we can better handle data and not crash, which is really good because we don't want to crash. So we'll get through the method stuff today, maybe most of it, and then on Monday we'll finish up doing the validation bit and maybe finish up anything we didn't get to yet on methods. So now methods are really handy. They're going to save us some time, some energy, some effort, but there's nothing we can't do without them. So it's a good habit, it's a good practice, and I think my favorite thing that they're going to do for us is it's going to put a nice name to what's happening in our code. Just like good variable names make it easier to understand what your variables are doing and what's happening in your program, a good method and a good method name make it clear on what this bit of code is doing. And we'll see what that's about here in a second. If I have a project, I'm going to call this methods for the morning. Yeah, we did got through all of Chapter 5 last night with the Tuesday class. But we'll do some of it this morning. We'll finish it up come Monday for you folks. And then we will have a little bit of time at the end to do some practice, work on the project, whatever else is coming up. All right, so we've been using methods already. Let me close this one down here. And in that, everything we've done is inside of this main method. All right, so all of our code we've put so far has gone inside of this public static void main string square braces args. So this is the main method here. And this is actually where Java looks. When you start a Java application, it's going to go start in the main method and do things here. So we're going to always use this public and static keyword. They don't make a whole lot of sense yet. Don't worry, we'll get to it next chapter. Just for now, everything's public static. Then there's this void word. Void is a keyword that says, hey, I'm going to just do something, and that's it. So main just does something, and that's it. There's no other returning kinds of values. So we've done other methods like that. So system.out.println, println, if you give it a string, it's going to go and do something, and that's it. So this is a void method here, println. So we've been calling a method called println all along. It just does whatever it's supposed to do. In this case, it spits something out to the screen, and that's it. We have done other methods. So like if we make a scanner, we'll call it keyboard. A new scanner, given system.in, and then we say, hey, enter a number. Oh, let me add the import for scanner here. Thank you. And we say, hey, here's my number is integer.parseInt. So parseInt is a method in the integer class. So it knows how to do something, and parseInt gives you back something. It returns a value to you. That's why we can assign whatever we get back from this, integer.parseInt, and we're going to assign it to number. Well, what are we going to give it? We're going to give it the keyboard.nextLine. Keyboard, this next line is a method that's been returning the string of whatever the user's typed in. So anything that we type in at the console and we hit enter, it's going to get returned by this next line method. And we're going to hand that to parseInt, turn it into an integer, store it as number. So we've been using methods all along, so now we get to write our own. So if we wanted to write our own method, it happens outside of these curly braces here, outside of the main curly braces. So we're still inside of our class curly braces. So far, we've pretty much just left this alone. So public class, the name of our project here, and we just left it alone. It's all fine and good. Inside of this set of curly braces is where we're going to be creating new methods. So they live at the same level or the same scope as the main method here. Usually I like main up at the top. Some people say main at the bottom. I don't really care. Any way you want to do it, sure. But I'm going to leave main at the top, and I'll put my other methods down below. So I'm going to come down below. I'm going to use the public static keywords here. It's public and static, and then I'm going to use void, because we're not going to return any values right now. We'll get to that in a little bit. I'm just going to do something, and we'll just call this one, I don't know, print hello. And then hello, there we go. And then a set of parentheses. Let me pull that up here. So print hello, a set of parentheses, and then it gets a set of curly braces. Everything inside this set of curly braces is going to happen when we run print hello. So in our case, it's not very interesting. We'll just say, hi there, and maybe happy Wednesday. And that's all it's going to do. So it'll run hi there, it'll run happy Wednesday, and that's it. If you want to use this method now, if you want this code to run in main, we say print hello. So instead of saying happy Wednesday up here, I'm going to say, hey, run this print hello thing. So it will get to here and say, oh, okay, you want print hello? I'm going to go jump down to line 19, do everything inside of this set of curly braces, and then I'll come back to where I was. So if we put this in debug mode, it's really cool. You can watch it happen. So I'm going to come over to this line numbers. I'm going to put the breakpoint in, and I'm going to run with the line numbers, the debug mode here. Maybe it'll run. It's thinking about running. It's almost there. Oh, I think my settings are wrong here. Let me check that compile setting. It says it ran, but it did not. Let me try that one more time. Maybe now I'll actually run my program. There we go. That looks better. All right, so this green arrow, right, is the current line that we're waiting to execute. And you'll see over in this top left, it's really small, I'm sorry, but it has this line here. It says, hey, main or methods morning dot main colon 10. It's saying, hey, I'm currently at line 10 in the method named main in the class called methods morning. So that knows where it is. We're tracking where it is. So before we've used the step over button. If you step over, we're going to go over the method. So what we want is this step into button, 2 over, that looks like a down arrow. We want to step into the method. So I'm going to use the step into button, and we're going to see it jumps. Now we're down at line 20, and over on the left, it's still tracking where it was, where we left off. So I have from main at line 10, now I'm at print hello, line 20. So this here is called the stack, the execution stack. This is how Java tracks where it is and where it needs to go when it's done with a particular method. Okay, and then we'll see I can step, I get hi there, I step, I get happy Wednesday. So if I go look at my output, I see hi there, I see happy Wednesday. Great, we're going to step. Now we're back to where we left off. We finished line 10, now we're back at line 12. Great, we do the scanner thing, we enter a number, and it's going to wait for us to enter that number. It doesn't look like it's running right now, but it's waiting for that input. So I'm going to go over here, I'm going to type 10, and I want to make it crash on purpose. What you get here is called a stack trace. Right, what we were seeing here, this stack, it was, hey, here's the method, here's the line we're currently at. We were at our main line 15. From there, it went to java.lang.integer. It's part of the Java API here. We're at line 778. If you cared, we could go look at what that actually is. We don't care that much. And then we're at line 660. And then we were at Java Lang number format exception. Number format exception means we crashed. But we'll see this is the stack trace. So internally, we've seen this sort of stack tracing before where, okay, so we were here, then we went to this method and this method and this method, this place, this place, this place. Java tracks all of that for us. So if we come back to our code, if I put all of this in, let's do another method here. So I'm going to come down, we'll say public static void ask the user for a number. And again, the naming convention is the same. Starts with a lowercase, and then every next word gets a capital letter. Right? So put a nice name to your method here. we can print hello, and then we can say, hey, ask the user for a number. Great. Let's run that. So I'm just going to hit run, and we'll make it crash in a second. And you'll see the stack trace will be different. So if I say 10, we'll say, okay, we were at main at line 10, then we were at ask the user for a number, line 22. Then this integer stuff, the number format exception, hit number format exception, we crash. So we'll see it was tracking the method we were in that stack. So a method can call a method, can call a method, can call a method, can call a method. You can go nuts if you want. And we can have methods that call method. There is some upper limit. I don't actually know what it is. For our purposes, we're not going to hit it. When you take the data structures algorithm analysis class, you hit it on purpose for fun, just to kind of play with it. But again, I don't remember what that number was. So our methods then, in main, this is sort of nice. If you just look at main, and you'll see, oh, hey, we're going to print hello, and we're going to ask the user for a number. That's all our program is doing. So you can kind of, just by the names of the methods, see what's happening with the program. Hey, Professor Burp, thanks for hanging out online with us on Twitch. Gotta remember to keep half an eye on chat here. Man, I got a tickle again. I did get my flu shot, though. I did not have a horrible time afterwards. I was pretty stoked. That was good. I got that on Monday after class. Feeling good so far. So we have a nice name. So if we want, we can make another method that our method calls if we want. So we'll say public static void, and the order doesn't matter. Java's smart enough to figure it out. Some other languages are a little bit dumb in that it doesn't know where the method exists if it's not above. Java doesn't care. We'll say print, I don't know, what do we want to say? Aren't methods fun? Aren't methods fun? Sure. And again, a set of parentheses, and then a set of curly braces. Then we can print, aren't you having fun with methods yet? And this method can call this method. Sure. This method could call ask the user for a number if we wanted. We don't, I mean, any order can happen here. Just do be careful you don't get in an infinite loop. Don't have this method call this method, which calls this method, which calls this method, which calls this method. Right? That's a quick way to crash. If you just go make a loop here where a method calls a method that calls a method that calls a method. That's bad. I think it should crash on us. See how far it gets. Aren't you having fun yet? Aren't you having fun yet? Are you having fun yet? All right, it hasn't crashed yet. It's going kind of slow though. So outputting stuff to the screen, oh, there it goes, is actually really slow in terms of computer operations. Right? The other things it does behind the scenes are super fast, but anytime you output something to the screen, it's relatively slow. So here's the stack trace. Right? We were at print hello, we are at print our method's fun, print hello, method's fun, yada, 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 back and forth, back and forth. Let's see, how far do we get? Woo, that's some fun looking output. Still more red, still more red, more red. All right, here we go. So this is starting to get something different here. In a print stream, buffered writer, output stream, stream encoder, char set encoder, UTF-8 encoder, byte buffer, stack overflow error. You might have heard the word stack overflow before. That was the joke when they made their website. So we put too many things on the stack and crashed it. That's why Stack Overflow is named what it is. So that's the fun story. All right, so let's not do that. But one method can call a method, and sure, we can be fine with that. Oh yeah, thanks, Professor Burp. I've seen that hotspot going around. Someone followed earlier, but I haven't seen actually anybody show up in chat. So this is like, we can't have nice things on the internet without people being jerks and trying to mess with people. This is really sad. I don't know why people seem to enjoy doing that. It's depressing. Oh, it doesn't show up in chat. Just if I see the follow. Tries to steal our IP. I mean, it's going to see the college IP address. I don't really know if that's going to do a whole lot because I'm not at home. Maybe that's a good thing. All right, yeah, if you know a good bot that auto bans, let me know. We can set one up later. So our methods. So far, we're just doing void methods. If we wanted to return a value instead, just like that integer parseInt returns a value, we could do that. So instead of the void keyword here, we say the type. So if I want to get a number, I can say, hey, I want to return a type of integer. So public static, and then void means nothing comes back, or something there, an int, a string, a double, a float, a whatever. The type tells Java that this method will give something back. So to give something back, you use the return keyword. We're going to say, hey, let's return the number. So it'll ask the user for a number, and then it will give it back. So up here I can say, hey, I want an int for number is whatever I get back from ask the user for a number. Right? If the method returns something, we can assign a value here. If like print hello doesn't return anything, we can't assign another. That's no good. And it's going to tell me incompatible types. Void cannot be converted to int. It knows that it's not returning anything. It's a void method. You can't assign that back here. So it just won't even work at all if you don't have that return type in here. And then it is going to double check, right? So if I tried to say, hey, this is a string number, it's going to yell at me and say incompatible types. Int can't be converted to string. Because this is returning a type of integer, I can't save it as a string. It's no good here. Sorry, sugar's high. Oh, barely, come on. Why are you complaining? I'm going to leave it for it. Might beep another in a couple minutes, sorry. I should be fine. So we give a type here. So great, now we have a method that asks the user for a number. Like we do this often enough, it's nice. So the other benefit then of a method, not only do you get a nice name for what's happening, is if I want a second number, I can use the method again. So I can say, hey, ask the user for a number. And now I can get two different numbers. So ask him for a number, ask him for another number. And it's less code, right? We don't have to do the print. We don't have to get this value. We haven't saved a lot of code, but we saved a little bit. And it just kind of makes the main method a little bit cleaner, a little bit more organized here. So we can see just what's happening. Sorry, let me mute this here. All right. So great. This is fine. We're asking for a number, but we don't like have any ranges. Like, did we want a number 1 to 10? Do we not want a number 1 to 100? Do we want a number up to 1,000,000? We don't specify, and all we're doing is saying enter a number. We didn't really give them a whole lot of info. So the next thing you can do with methods to make them more flexible is this thing called arguments or parameters. So we've been doing that already with our print line. Print line, you have to give something inside the set of parentheses. We're providing an argument to the method. We're saying, okay, I want to run print line. Here's the thing I'd like you to print. Or with integer.parseInt, here's the thing I want you to turn into an integer. Here's this value I'm giving you. Please turn this one into an integer. So if you want something to be provided to your method in the set of parentheses here, we say, hey, I want a string for, let's call it the prompt, a string for prompt. So you give me the prompt that you want to ask for, like enter a number 1 to 10, enter a number 1 to 1,000,000, enter a negative number, enter an even number, we don't care. Whatever that prompt is, you give it when you call the method. So now these are upset and they say incompatible or cannot be applied to the given types. Required string, found no arguments. So it's saying you need to give it a string to call this method. So sure, okay, so ask the user for a number, enter a number 1 to 10. And then this time, maybe we'll say enter a number 1 to 100. Now inside this method here, I have access to this variable called prompt. Prompt is going to be whatever they put inside the set of parentheses. So instead of printing out enter a number, I can just print out the prompt. Whatever they told me to print, I'm going to print. So when we run this, I'm going to have to get some Coke in a minute. Enter number 1 to 10, right? That was our first prompt. 5. Enter number 1 to 100, 50. Or, oops, 500. We got too many zeros. We didn't actually validate anything yet. We'll get there in a minute. But we can see the prompt is different because we used a different prompt when we called our method. So the code doesn't have to be exactly the same for us to be able to reuse methods, to be able to use a method to do the same. If it's the same process, this happens and this happens and this happens, and the only thing that's different is a particular variable, you can pass, it's called passing that variable to the method. Technically, our term here for this is a parameter when it's defined in the method. So I said I need a parameter of a string called prompt, and when you call the method, this is considered the argument you're providing to the method. They're basically the same thing. I have no idea why they have different names. I've never understood that. But if you run into somebody who wants to be technical, and unfortunately lots of people in the software world really like those stupid details, and they get really weird about it, sure, this is an argument, this is a parameter. Who cares? It's not important. Okay, so we got a number here. Great. Now, what if we wanted to do some sort of validation and say, hey, I want to make sure my number is within a certain range. Right? We've done validation loops before. Right? Well, that's from last week. Everyone remembers validation loops? Good, good. Lots of head nodding. That's good. So let's do another method. So public static int, I'm still going to return an int. Let's ask the user for a number in range. You give me a prompt. Now, I need to know what the range is. So what you can do is you can comma separate, and you can have multiple arguments. So a prompt for the whatever we're going to ask for, and then, here, let me bump this down a little bit because it's getting long. How about an int for the lower bound, and an int for the upper bound? And then a set of curly braces. Now, right off the bat, it's mad at me because it's saying you're missing a return statement. You never returned anything. We said, I'm going to return an int. It won't be happy until it sees that return statement. Which is okay, but it's so like, don't worry that it's red right away. If we're a returning kind of method, it's waiting for us. So I already know how to ask the user for a number, right, for a given prompt. Right? I don't want to have to do the same code again, so I can just use that exact same method. So I have an int for number. I'll say it is ask the user for a number given my prompt. Right? I'm going to use this other method that we already did. Then I can do my validation. Right? I can say, okay, while that number is less than the lower bound, or that number is greater than the upper bound. Board? Why did I say board? So you could just rename it here, but you want to get in the habit of using the tool. If I like manually type it here, I have to manually type it here. And if I have it like 3 or 4 or 5 or 6 or 7 or 8 times, I have to change it all 8 times. That's really a big pain. So just right click on it and go to this refactor menu and say rename. In here, it's going to automatically rename it every place for you. So I'm going to fix that to upper bound. It changed both of them. Right? Use the tool to work smarter, not harder. So if the number's too low or it's too high, let's ask them again. I'm just going to assign a new value to number here. Sure. Eventually, we'll get out of that loop, I hope, and I can not return 0, return the number. Right? Eventually, they'll probably give you a number that's within those bounds, and we'll get out of that loop, return the number. Right? Now, it's possible the person calling this method screws it up, and if the lower bound is larger than the upper bound, if they did them backwards, we're screwed. Right? Because you will always be, one of these will be true if you flip them. But again, that's up to the person who called the method to do it the right way. We don't really have a good way around that currently to fix that. But sure, so we can prompt them. Why is that? Okay, that's the alignment here is a little bit funny, but that's okay, just because it's long. All right, great. So if we want numbers in a given range, then we can use that method instead. We can ask the user for a number within range, the same prompt, would say 1 to 10. Cool. And then we'll do that same thing here. In a range, we'll give them 1 to 100. Let me bump that down a little bit. We'll give it a try. Right, enter number 1 to 10. If I give it 0, still says 1 to 10. -5, 20, Right? I'm stuck in here. Right? It's validating, making sure I'm giving it a valid value. I give it something within range, and I'm good. All right, 1 to 100. Like 1,000's too big. Nope, no good. Negative. Negative's too small. 40 is okay. And we're all right. So we can see we can use methods, and methods can call other methods. It's nice to not have to do the same code over again. You feel good about that? It's nice. And like once you've done this, you can just copy paste this into other projects. That's not the ideal way to do it, but we don't have the other ways yet. Like once we get to the next chapter, we'll figure out how that works a little bit nicer. But like anytime you want to ask for a number and you want to validate it, you can just copy these pieces of code in and use them again. Right? We've solved that problem. So the other great thing about methods, right? Not only do they put a nice name to what's happening, right? Not only do they let us reuse the code and reuse it in a flexible way, like if the only thing that's different is this one variable here, or a couple different variables here, I can still reuse it with my arguments and parameters. And then the third thing, it takes a big problem and it breaks it down into smaller problems. Right? Again, this is not the most interesting problem, but at some point, how do we validate a number that we asked for is a problem. So we did that in a small piece now as its own method. That was one problem that we solved. So any other time in our code now, if we need a number within a certain range, we can just go use this thing we've already done. We don't need to solve that problem again. Right? Kind of like building out there's the Java library of all the things Java knows how to do. We're sort of like adding to our own library of code of things we know how to do. Problems we've already solved, which is fantastic. We okay so far? All right, so this was using a couple different arguments here. We can do another one for fun. Let's do public static. Let's do a double here. And how many of you are familiar with the quadratic equation? Let's think back to math class, because math is fun. All right, I got one person who likes math.
Oh, no, I don't like it.
Oh, you don't like it? Okay, you remember it. KTorrent, yeah. You could use the arguments, the lower bound and upper bound, to fill in the prompt yourself, yeah. We could be smart about that if you wanted. So we could do that real quick. So public static int ask the user for number between, and then int lower bound, int upper bound. So we could print out, enter a number, and then append in the lower bound, append in our dash sign, and append in the upper bound. Right? That would be our prompt essentially. Right? We could do that. So the reason prompt might be nice is that they might want to give like some more information. And if the only thing we do is here's the lower, here's the upper, sure. I mean, maybe that's fine. Just depends on what we want to do with it. Right, and then ... again. Hey, okay, let's cheat a little bit here. So let's do, hey, I want a string for prompt is this thing here. Let's see if I get rid of that. Okay, we'll concatenate all those all together, and then I can return, ask the user for number in range, given my prompt, given the lower bound, given the upper bound. So you don't technically need to save the value before you return it. You can just return something. Right? Right up here, I could just return this right off the bat. You don't have to save it first. I like doing this because in debug mode, I'll get a chance to see what it is. That's the only reason. So like saying, hey, return, perfectly fine. Or we could say int number equals, and then we can return the number. Sure. Either one's perfectly fine. So this way we build our own prompt. This time we give them the prompt. So you just have to make sure you can't have two methods with the same name with the same list of parameters. You can technically have two methods of the same name as long as the parameter lists are different. Java's okay with that. That's more of an advanced topic we'll talk about next chapter. All right, so let's do our double method. Let's do another one here. So this was, how about calculate first y-intercept. Given, now, I feel a little bad, but the mathematical formula for a quadratic equation is ax squared plus bx plus c. So the variables are really a, b, and c. right? They're awful variables, but that's literally what they are in math. So we just need a double for A, double for B, and a double for C. Right, and you remember that equation? It was x equals negative b plus or minus the square root of b squared minus 4 times a times c, and then everything divided by 2a. Right? I don't know why that's still, it's been in my head since middle school math, and it has not been all that useful to know. But some things are just stuck in your head, so sure. All right, we can figure that out, right? We can have an int for the first y-intercept, right? So negative b, sure, negative b. Now, I can't do plus or minus. I can only pick one, right? So do you want to do the plus or do you want to do the minus? Plus. So we'll do negative b plus square root, that's math.square root, right, of b times b. Right? You could do like to the power, math.pow, b and 2, but it's just b times b. We're not really saving anything there. Minus 4 times a times c. Right? All of that then. Oh my goodness. Why did it give me too many parentheses? All of that divided by 2 times a. Now, this will bite you with order of operations, right? This would divide by 2 and then multiply by a. To divide by 2a, you need a set of parentheses again. Oh, that's not an int. That's why the whole thing's upset. It's a double. Okay, now I have my first intercept. Cool, we could calculate the second one too. Right? We might as well. Now, the sad thing is you can only return a single value from a method. So I know there's 2 y-intercepts, or possibly 2 y-intercepts, or possibly none. We can only return one. Right? So I can calculate them both, but I can't give you both back. We'll have the second, and then we can return the first y-intercept. This will calculate our intercept for a quadratic equation. You folks seen the site Desmos? Fantastic math site. Apparently it does more than just math lately. We're pushing hard for new features for things. But the graphing calculator is fun. So if we come up with some A, B, and C, right, we can just pick any numbers, if throw any out. 4x squared plus 8x plus 10. So that one's not going to have any intercepts. How about we do minus 10? Can we say minus 10? So our intercepts then will be at 0.871 and negative 2.871. That's where the graph intersects the axis, right? Okay, that's our first y-intercept. So y, right, where y equals 0, we're intercepting. Is the name wrong? I'm not a math teacher. Mr. Tim should correct me. Okay, I always get those confused because it's the x value where we intercept, because this is the y-axis, right? So it's really where we're intercepting the x-axis? Is it an x-intercept or a y-intercept? X, okay, it is x. See, okay, let me change all these to x then. X. Yeah, where we intercept the x-axis. So it's the value of x where we hit the x-axis, where y equals 0. Sure. Again, it doesn't really matter all that much. So let's try it. So we can ask the user for a bunch of numbers here. So ask them for, enter an a value, or a value for a, right? And again, the range doesn't really matter too much here. So maybe we don't do that prompt for range, because any value is technically valid in mathland. So we'll just ask for any number here for enter a value for a. Okay, and we'll do the same. So this will be a. They're really doubles. We don't care too much. Integers are fine for our purposes. We'll do b and c, b and c, b. C, and then we'll get our x-intercept, our first x-intercept will equal the calculate first x-intercept for A, B, and C. And then we can print out the first intercept is plus the first intercept. So we should get the largest one, right? Because we're doing our plus arithmetic. So let's give this a, no, not that, a run. Right, so we had 4, 8, and negative 10, right? It's not positive 10, it's you're adding a negative 10. Is how those work, right? So 4, 8, and negative 10. So 4, 8, negative 10 gets us 0.87. And hey, look, we're even more accurate than the graphing calculator is. They round off at 3 digits. We're more precise. Right? And remember, Java is happy if you ask for something that is a double. An integer fits inside of a double, so you can give it an int, right? But if you ask for an int and you try and put a double in there, right, you're jamming too big of a number into a smaller one, it's going to complain because you could lose detail. So these say, hey, I need a double for A. We gave it ints, and it didn't complain, right? You can always go smaller to larger, but you can't go larger to smaller. Okay, so we did another method here, right? And then this now we can use anytime we want to calculate some x-intercepts. We can just add it to our library of things that we know how to do now. Right, it's another method that does something. How are you feeling so far? Looked at a lot of methods. So void methods just do something and stop. Value or returning methods will give you back a value. Right, so they'll do something and return a value when they're done. So we can assign the results of the value returning methods right away. To give us some more flexibility here. Let me take a peek and see how we're doing on methods. All right, so we didn't do the exception handling yet. We're going to save that for Monday. So now let's make this a little bit smarter here when we ask the user for a number within range. Right? Let's see if we can make this a little bit more flexible. Because it's possible that you don't want to give me a lower bound, and so you'll say, hey, here's the minimum possible value for an integer. Right? I want no lower bound, so they can go as low as they want, so we give it the lowest possible bound. So we can check, we can say, hey, if the lower bound is equal to integer.min value, right? If they give me the minimum value for that, then they don't actually want a lower bound. So the only thing I care about is that upper bound. Right? Okay, so we're going to check. So if you tell me there is no lower bound, great, we'll run with it. So we're going to essentially do the same thing here, but my while loop only cares if I'm too large. Right? So you can have more than one return statement in a method. It can be a little bit confusing sometimes, but as soon as you hit a return statement, the method stops. Nothing else in it executes. So if this is true, we go into this block of code, we'll return, nothing below it will ever run. Okay, not too bad. Now, what if they also said they don't want an upper bound? Right, I can check for that too. So if really we want to check for both. So if they give me lower and the upper bound is equal to integer.max value. Now again, this is kind of silly on their part because we had a different method that didn't validate. Like, why call the method that validates if you don't want any bounds? But sure, no big deal. So we didn't need anything, so we just needed a number here. Put in number. So if they don't have any bounds, we just ask for a number. We're good. Okay, whatever that prompt is, sure. There's no validation that needs to happen because you said anywhere between lowest possible and largest possible. All right, fine. So because we have a return statement here, we don't need to put else if. Remember, if, else if, else if, else if, those chains make it mutually exclusive. But if you hit a return, you can't get down to the next block of code. So if this one's not true, we can check the next one. If it is true, we're going to return, we're done anyway. So it being standalone ifs is perfectly fine. It doesn't need to be an else if with that mutual exclusivity because we're returning and ending anyway. So one of them will only run anyway here in our code. So let's do the same thing one more time then for checking for the upper bound. So if their upper bound is the max value, then we only care about if we're less than the lower bound. We'll prompt them again. Right? So if they have min and max, we just ask them when we're done. If the min is the lowest possible, we only need to care about going over. If the largest possible is the max, we only need to care about going under. And otherwise, we want to do the same thing we did before, right, where we check them both. So we have a couple different things happening in our method here now, checking this range to make it a little bit smarter in case they want to say, hey, don't give me the lowest possible or don't give me the largest possible. Right? Oh, Professor Perp Online wants a dad joke. You got it. I've got some good ones here. So I tried briefly a career in roofing, but I didn't make for a very good roofing salesman because I kept telling people when they asked how much it cost, I said, it's nothing, it's on the house. They didn't think the joke was all that funny when you actually give them the price tag. All right, cool. So we got through some couple methods. All right, someone, I Am Wolf says they actually laughed. Does that mean it's a bad joke then? Like, because dad jokes are supposed to be terrible, so you groan, not actually laugh at them. They're not supposed to be funny, right? I can't tell. Like, is it more successful if you laugh or more successful if you groan?
Sometimes you laugh and you feel a sense of pain on that.
So we have to judge how good the joke is based on how painful it is?
Yeah.
I like it. I like it. All right, I think I had one other one. That was a good one too.
Mental scale like earthquakes. Yeah. Like a pyramid earthquake, like double the last one. So like level 10 dad joke is twice the
Twice as painful.
yeah. Exactly.
It's an exponential scale, right? So we all know that 6 is afraid of 7 because 7 ate 9, right? But why did 7 eat 9? You know, everyone kept telling him you need to eat 3 squared meals a day. That's a math one, too. I love the math ones. Those are awesome. All right. So we got a lot of methods here. We're just adding tools to our toolkit. So nothing that we've done couldn't have been done without methods, right? We would just have to have the same code in here more than once, perhaps, but we still could have accomplished the same task. So again, we're looking at gains for us humans, right? We put a nice name to what's happening. We can possibly reuse some code, right? Hey, I have 3 different prompts here. I don't need to do the same thing 3 different times. Great, sure. And then we can break down a big problem into smaller and smaller and smaller problems, right? So let's take a look. I'm going to start. Oh, not undo. No, not undo. I'm going to start a project 2. A shell of a project with just methods and say, hey, if I were to solve project 2 using methods, which they're optional, right? There's no points in the rubric for doing it with methods. You don't need the methods, but if you want to practice them, great. Let's do project 2 warning shell. We can look at how do I take a big problem and break it down into smaller and smaller and smaller and smaller and smaller problems just by putting names to things. Right? It's a little overwhelming to say, hey, this is the entire big thing I have to do, versus, okay, let's do this step, let's do this step, let's do this step, let's do this step. And you can figure out those steps later. Right, so let's pull up D2L here real quick. Maybe it'll load for us. Yeah, we can leave Desmos. And I think D2L is cooperating now. I finally did get it posted, like 2 p.m. or so, I think. It's kind of a bummer with a big outage. All right, let's take a look here. I think I had everything in here, and we should have the rubric now as well. That kind of maps out how we earn all the points. So it's worth 11 points, so a little bit more than the previous one. Okay, our little hangman game. Okay. So the first thing we need to do is ask the user for a word or phrase to guess. Right? Sure. So we'll have the string for the word. I don't know, word to guess. How about that? Is ask the user for the word to guess. Boom. if we know we're going to assign a value, we know this method will have to return something, right? So we'll have public static string, right? If we're going to need a string value, you know, I don't have to type the whole thing again here, so I'll just do that, copy paste, set of curly braces. Now it's going to stay red unless I give it something. So for now, I'm just going to say return just an empty string, just so that the red goes away, so it makes me happier. Sure, you know, obviously real stuff has to go in here. But okay, now we have a word to guess, right? Cool. We're going to ask them for the allowed number of incorrect guesses. Okay, sure. So we'll have an int for number of allowed incorrect guesses is, yeah, you know, we could get a very long method name here again, or, you know, ask the user for a number. What do we call our other method here? Within range, right? Ask the user for a number in range, right? And then, you know, whatever the prompt is here, and valid values, right, between 1 and 26. Hey, we already solved that problem. Look at that. That one's done. Just copy paste it over, right? Okay, we already did part of that. Sure. Well, we can reuse that method. Right here, whatever, you know, you can fill in the prompt here, right? Cool. That one's done. All right, sure. Okay, we got to go copy paste it over. And let's see. We need our number in range. That one's big and ugly. That's fine. Oops, I put that, excuse me, outside that curly. It's got to be inside the class curly braces here. And then ask user for a number. We need that one too. Look at that. Oh, yeah, add an import for scanner. Okay, awesome. Life is good so far. Cool, so we got our number, right? That's our validation loop, great. And we're going to loop until they've lost or they've figured out the entire word, right? So, you know, while is a, or I don't know, is still playing here. Sure, we can do something, and this is still playing method then wouldn't have to return what type of value if we want to put it inside of a loop. What type of value do you need to do a loop? Remember, it has to be true or false. A Boolean. So we can have a Boolean, you know, is still playing here. And then it can return a true or false. Again, you know, figure it all out. I'm just going to put false in for now. But okay, if we're still playing. So in here, then we can figure out, hey, have we guessed all the words yet? Or have we guessed all the letters correctly yet? Or did we run out of guesses? Now, the other thing we haven't talked about yet is how I can use variables in different methods. So inside of, let's see, where's a good method here? This one here, I have a first x-intercept and a second x-intercept. They only exist inside this method. Like, remember when we had an if block? If you declare a variable inside the if block curly braces, it only exists inside of those curly braces. Same thing goes for methods. That's called the scope. So when you declare a variable inside of a method, it only exists inside of the method. Which is, you know, usually what you want, right? You're going to use it for what you need your purposes, then you'll be done with it. Here. If you want to use a value in more than one method, right? We can either be passing it and returning it all the time, but that can be tricky. You see, like, if you can only return one thing. The other option you have is to use class level variables. So you can define a variable outside of methods, but inside the class, if we want it. So we could say, hey, double for first x-intercept, and a double for second x-intercept. Now, generally, we frown upon this kind of thing. The next chapter, we'll learn some better ways to do these things. I'm sorry, public static. Sorry, we need our public static keywords here for these. Generally, we frown upon this kind of thing, but for now, you know, it's the only tools we have in our toolkit. So we can go and set those values now. Instead of saying, hey, I want a new method or new variable for first and second intercept, I can just go set the values of them here. And really, we could just be a void method at that point, right? We don't even need to return anything. Let's just go calculate them. And I'll go set them here. And I can print out the first and second intercepts. Second intercept. Okay, so because they're declared at the class level, outside of methods, anything inside of that can see it. Right, so we've expanded their scope. So now they're available more places. Again, this is a little ugly. But don't worry, we haven't really learned what to do, a better way to do it yet. And that's okay. So we'll be fine. So in your project 2, right, you could have a class level variable here for like int public static int number of wrong guesses, right? You could have a public static int number of allowed incorrect guesses, right? That sort of thing. You can have these sort of values here, right? And that way you can get at them from other methods, not just inside of the main method. So that's an option, right? Just an option for you. All right, so figure out, right, inside of that loop then, right? And then for each round then, we're going to display the word or phrase. So if we're still playing, we will display the word to guess with blanks, right? And then we will display all the previously guessed letters, right? And then we will ask for a new letter, or I don't know, ask user to guess a letter, right? We can do this step and this step and this step, right? Sure, we can do those three. Then we can do all those things. So the first one is probably void, right? That's just a display. So public static void do something, right? The next one probably still void again, right? Public static void, right? They ask a user for a letter to guess. This could return the letter, and we could do something with it, or it could do that operation inside the method. Totally up to you. I mean, either way is going to work. Right? If you want all that to happen in the method, great. If you want it to return the letter and then do some other checks on it, go for it. Whatever you want to do. For now, I'm just going to put it in as void. And maybe leave a note, this could return the letter if you wanted. Right? We could. Sure. Okay? Don't allow them to guess the same letter twice. And all this in a loop asking if they want to play again. So this guessing a letter here, right? Make sure they don't guess it twice. Don't guess the same letter twice. Twice, sure. And then all of this needs to go into a loop then, right? For, do you want to play again? Right, so we'll have, I don't know, like a string play again equals y, right? And then while play again equals ignore case. As long as it equals a y, let's keep on going. So we're going to start the loop once. Again, you could do a do loop. I hate do loops purely because of that stupid semicolon. So I will work very hard to avoid do loops because they irritate me. So we know we're going to run at least once, and then we should ask them when we're done, right? Do you want to play again? And I think we had a prompt just for, do we have a prompt just for a string? No, we didn't. We only did numbers, so sure. I don't know. So again, equals, ask the user if they want to play again. Right? Play again was our string, sorry. And we can have another method. So if it's going to give you, if you're going to set a string value, it needs to return a type of string. Right? So again, I'm just going to, for now, put in a nothing. Right? But this now is essentially Hangman. Right? With none of the actual stuff working. But okay, hey, we're going to play again. Starting yes. As long as we want to keep playing again, let's loop. All right, get the word to guess. Get the number of allowed incorrect guesses. As long as we're still playing, display the word. Display all the previous guessed letters. Ask them to guess a new letter. As long as we're still playing, great. And then let's play again. Right, that's Hangman. We've done this process of taking a big problem, breaking into a smaller one. So now you have a lot of small problems to solve. Hopefully it feels a little bit nicer here. So our technical term for that, which is one of my favorite technical terms out there, is called functional decomposition. Taking a big problem and decomposing it into smaller and smaller and smaller and smaller pieces to solve. It's like the best one to throw out at family parties because everyone looks at you like you're crazy. And then you're just like, yes, I am the king nerd. I mean, you got to own it a little bit. Although it's tough because my brother is also a programmer, and my sister is. She went to school for engineering, but she doesn't do engineering for various reasons. So I don't think she qualifies as the queen nerd. So my brother and I have to fight over that. So it's fun when both your parents are engineers. So you kind of embrace your inner nerd. It's good. All right, so I'll put this out here. If you want to use this as a starting point, go for it. You're more than welcome to start this. So what I suggest you do is good habits, right? So cite your source. Cite your source, right? Put URL here, right? The URL you go find it on github.com, just put it up at the top, right? That's citing our source. We're great. Okay, if you don't do it, I know you probably got it from me for this one. If you give me someone else's Hangman game, right, we've done a bad thing. Remember that we've explicitly said that. Just like an English paper. You can't turn in an entire paper and say, oh yeah, here's my source, I cited it. Of the entire stupid paper. That would not fly, right? If you find, hey, here's one little piece here, and I want to cite that one piece, perfect. That's what you do in English papers, right? You can put together multiple pieces, adding in your own original thought, right, to make that finished work. Same rules apply, okay? But I think from here, it's probably not the hardest thing in the world to go finish. And I think definitely doable. But that's sort of the goal here. And that's looking at why methods are so awesome. Let me go commit all this stuff to GitHub. We're going to save the exception handling for Monday. And we'll call today done. I'm going to go out and get some Coke. We got some time to work on stuff, do some practice. That's usually the goal is about an hour or so of me talking, and then the rest of the time for you folks to practice. If I spend all hour 50 minutes talking, you're just going to get really bored. I mean, I'll get bored too, so just to be honest. All right, so here's methods from the morning. I'll put that out there. The Tuesday class has a different project 2 from you, so make sure you find the right project shell. I mean, I think when you look at it, you'll notice it's different, obviously, but just putting that out there. Yeah.
I have a question about one of my projects.
Yeah, give me 1 second. Let me wrap this up, and then I'll come over there. Someone online. Yeah, Professor Burp, you had a question? So when you purchase something, you need to find the value of that, and you're going to subtract it from the user's balance. Right? So the user should have that balance, whatever their current balance is, and then you're going to figure out the stock that's being purchased times the quantity times the current price, right? And then take that away from the balance. Yep. So it'll be an update. That's a different class. Yep, I realized that. No, so that's when you buy. Yep. All right. Oh, did I have more things to save? What was different here? Yeah, no problem. All right, folks online, I'll be hanging out. If you want to ping me on Discord or text me, I can answer questions as well. I'll be hanging out in class till we're done. Let me just go grab a Coke first. See ya.